information center. This is the information center.
Is a game box. If you're not familiar with these tools, we'll start with the basics. If you come over to this side, you'll see the little drop down menu. And I've used this game box. And the settings for that, as you can see, I've just used 0.5 and 1, and the rest of them are 0. What this does is gives us a simple box with an outline. So what we're going to explain here.
You, I don't think.
Okay, yeah, I've just started to talk. Every now and then I'll go silent. I'll speak when we're going to show something of relevance at the time. So what we have here is this is the basic game box. If you understand how, what you'll notice is that there's these X points, and if you understand how the time to price relationship is going to work, you understand that for some reason there's an X happening here. To work out what it is, we obviously need to work out the time span to get to this point. Well, if this is 0.5, well, we know that there's going to be a halfway point there, because if this is 1 and this is 0, we obviously know that there's going to be a halfway point, which this is. If there's a halfway here, then we obviously know there's another halfway point, which is represented by this X. So to show you exactly what we mean, so as you can see, finding that X point is relatively simple. We now know that halfway from here to here, we've got another halfway point. There's a interesting topic about if you was to carry on going halfway and halfway, there'd be an infinite halfway point. So obviously we know now there's another halfway point here. To get that halfway is fairly simple, because if I was to add these 2 points together and then divide them by 2, obviously that would give me the halfway point. To make it really simple, I'll bring up a calculator. Okay, so all I've done there is obviously started to cut this division up into sections. You can see that by visual, there's obviously one missing there, isn't there? And that's easy to find. It's just half of 0.25. So if I was to add that to here as well, you can see that there's a natural harmonic there of what's now become eighths, because this is 4 divisions. There's obviously the other half of this box, which would complete the 8. Now, this still doesn't give me a reason why this X is here. I've worked out this one, and it's now giving me this point here, which still doesn't even get this one, because I can see an X here. So this is an interesting point that I haven't been able to find. It's not a halfway point, which I was expecting. So let's find that. Obviously, I know what that is, so I'm just going to cut to the chase and get that point in. So it's interesting that this half has got some sort of a relation to 333, which is 1/3, because if I again got a calculator, so clearly 1 divided by 3 is 333, and then it'll be 666 to make there, which is interesting because now I've got this x point and it's given me some sort of a relation to 0.5 and 3. 1 moment. Oh, okay. Dorian, you okay? You can hear us okay now? So what we're actually establishing here is that there is some sort of connection between these two numbers, but down here, there's others happening. We got the 0.25, which was here, and we got the third. So what I can do, okay, so what I've got is the standard 0.5 box, which I showed, and I've identified this 333x here, and we obviously know if you folded it in half, we'd have the same point over here. We know that this is 0.25, so if we keep this separate as well, because the whole idea is that the colors, otherwise it'd just be a mess of lines and a web of the same color. So we want to be able to distinguish the difference between anything that we put on the chart. So we're going to put another one so I can actually see the 0.25 and the 7.5 in their own color. Okay, can we all see that we've now got a division there of the quarter, the 0.5, 3/4, 1/3, 2/3. Now, if you look carefully, we obviously know that this is bringing up another x here now, and here. Look carefully. Can you see these points? So let me just mark them with a vertical line. So as you can see, we was talking about half and halves. Well, this here is 125 because we can see that there's a clear x that's made from this half. The x there is 125. So what's this point? Well, if you come to the third and you look how the x of that red comes to this point, well, that obviously must mean that it's halfway of the third.
So by
Are
doing
there?
this, I, by doing this, I think we could have infinite numbers of x's.
Yes, of course. That is exactly that. Because if you was to be able to go down into the quantum level, we could obviously subdivide this into as many as we wanted. The purpose of this is that there's going to be some governing numbers that will be in control more so than a smaller number maybe that's within these. So for example, if there was a number here or an x here, which eventually you will get, look, you can see one that's going to come here. Well, that might not be significant because it's not got a harmony point that means anything significant. For example, if I said to you, you've got a Mars bar or a Coca-Cola and it's at half price, well, you might want to buy it because it's cheaper, it's half price. But if it was, say, it's seventh off, it's a seventh cheaper, you'd be like, well, that's meaningless. I don't really care about it being a seventh cheaper. Who cares? Does that make sense? So there's
Yeah,
numbers that are going to be significantly more
important.
important to the individual person, as well as obviously to the algorithm that will be in control. So, for, like I say, if the point was to be getting into a harmonic point of, let's just say here, this is 0.75 by 0.25, well, this has got some sort of a harmonic value because it's creating a point of 1. If you was to add these points together, this is obviously 0.75 plus 0.25 gives you a value of 1. So if you're getting to a harmonic value of a 1 or a 360, this equates to the same thing because a degree of motion would be equaling like one whole degree of motion would be equaling to 1 on a point. And that's the same example here. You're now at 666 by 333. So for example, if the price was to come up into this point here, you might expect a reversal to come down to test one of these levels. But if the price was to come up to here, where there is no real harmonic value, it might come through to test the value above it, to then come back down to test it on top of that harmonic point. But anywhere that you would be within this line is a harmonic point on its own. Because if price was to go up 1 point, along 1 point, sorry, along one, up one, along one, up one, well, this has got a value of 1-to-1 price increase. Does that make sense? So if I went up 10 days and 10 points, I'd be here. If I went up 1,250 days, for example, and I went up 1,250 points, or I could have gone up 12.5 points, or I could have gone up $1.25, because in the eyes of man, like many of my heroes, which is one of these quotes are from, is that the decimal point has no value to us because we don't value a zero and we don't value a decimal point. So we can remove them if we like, or we can choose to move that decimal point as well. So this 0.125 could actually be 12,500, or it could be $12.5, for example. Does that make sense?
Yeah, I got it.
So the reason that we're establishing these harmonic points and a value is that there are some key harmonics that will work for set things, whether it'll be to do with charting or whether it be to do with music or whether it be to do with anything else that you can use this to, whether it be building bricks, putting windows, it's all the same mathematics that's governing us all, whatever you use this for. So what we're trying to do here is actually establish that if we are getting the right and the correct mathematic base, then to be able to expect certain reactions within these points is a given for us. And this is the whole point of being able to learn and understand the mathematics and what they're actually doing. So if we carry on a little bit longer, what you're going to actually see, I'll show you, is I wanted to get the final few points in here, which will be the halfway point between the thirds, which now goes into the sixths. So to add that again, okay, so now I've found them points. I'll just remove the vertical lines there so that wasn't confusing it all. As you can see here, we're starting to understand that there's some sort of a division here that's going to be fundamentally there for whatever we use this on. I have one half missing here and here, which we found earlier, which was the 375, which we need to add. Okay, so in this web of numbers and angles, you can see that we've identified the eighths divisions, which is 125, 0.25, 375, obviously the 0.5, 625, 75, and 875. So this is now giving us an eighths division of this box, as is this is giving us the sixths or the thirds, which way you look at it. So as we now have these numbers on here,